Okay, so you're welcome to class, everybody. Thank you for coming. And in our last class, we look at connectivity to AWS. And when we say connectivity to AWS, we are saying, how do we connect to our AWS, our resources in AWS, our virtual machines? Can you hear me? Yes.
Your presentation has gone. No. I don't know if I'm the only one. No. Please, can anyone confirm that?
Okay. How about now?
Yes, I can see.
Okay. All right. So we are saying that connectivity to AWS, how do we connect to our VPC? Okay, we've mentioned VPC. Can anyone explain what he or she can remember or recall from VPC? Anybody?
Virtual private. Okay. PVC is connecting privately through virtual private network.
VPC, we said a VPC is a networking service that we can use to establish boundaries around our AWS resources. And I remember giving us an instance of having an estate within Lagos. So you have your own services, and you are saying that AWS, just give me an apartment. In this apartment, I am going to decide how I do my own things. I put my own security policies there. So that's what we are saying in VPC. Just like imagine the millions of customers who use AWS services. Imagine the millions of resources that these customers have created. So if everything is just lying anyhow, people have to bring in the virtual private cloud in order to have your own AWS account within AWS. So that's what that is simply saying. And I remember after that, we spoke of we look at the features of a virtual private cloud. And we said the first thing here is what? The internet gateway. Can anyone recall what internet gateway is? Miss Regina, read this for us. So we take it up from there.
Is everything?
Yes, read for us.
Okay, internet gateway. An internet gateway is a connection between a VPC and the internet in order to allow public traffic from the internet to access our PVC. We attach an internet gateway to the PVC. You can think of an internet. Okay.
So we are saying that anytime we want to connect our VPC to the public network, we need to attach an internet gateway. He said you can think of an internet gateway as being similar to a doorway that customers use to enter our coffee shop. We have this explanation in the last class. So, and from there we look at this. This is an internet gateway. This is our VPC inside AWS. This whole black infrastructure is AWS itself, the AWS cloud. But inside the AWS cloud, we now come up and say, okay, Regina Eatery now decide to have its own VPC that is going to be like another AWS, and inside it, Regina has some EC2 instances, has a database, as load balancer. We know what a load balancer is, right? How load or traffic are distributed among these EC2 instances. And we see auto-scaling group, that this auto-scaling group is saying that if there is too much load on these three, create additional EC2 instance. Are we still here, please? So, internet gateway now is saying that if I want to access my VPC from my house, I need this internet gateway. So we say it's like a door that leads to the coffee shop. All right. So I have another diagram again that depicts that customer, a client sent a request through the internet and into the VPC. So you need the internet gateway in order to access your VPC. So the second thing is, read this for us, man. Miss Regina, read for us. Can you hear me?
To access.
Okay. Yes, read on, read on.
To access private resources in a VPC, we use a virtual private gateway. Let's talk about a VPC with all internal private resources. We don't want just anyone from anywhere to be able to reach these resources. We don't want an internet gateway attached to our VPC. Instead, we want a private gateway. What is it?
Thank you. Now, look at this diagram here. Can you see my screen?
Yes, sir.
Now, this is your database. Okay? In this database, Regina, are you here, please? In this database, you have your customer name, you have your certificate. This database, you will make it a private one, that it is only people within your organization that can access it. Maybe some certain people, like your account department and all of those ones. So this kind of resources, you don't make it public, so you don't need an internet gateway. Any resources that is on a private network needs a virtual private gateway. Now, we said the virtual private gateway is the component that allows protected internet traffic to enter into the VPC, like your on-premise data center or internal corporate network to your VPC. Now, look at it now. Look at this diagram. You see, here now, you see the normal internet, but there is a virtual private gateway in here. You see that when they want to show something now, they are showing database. They are not showing C2 instance, because it's in this database that most times they are private resources. Are we there? Hello? Are we still in class, please?
Yes, sir. Yes, sir.
Okay. I can't hear Regina. Regina, are you in class, please?
I'm here. I don't know. I'm a person. I cannot see the presentation, but I can still hear you.
Oh, you can't see the presentation?
I can see it now. Don't worry. I've been able to.
Okay.
I was struggling to.
Okay, sorry. All right. So, like I was saying, look at this virtual private gateway here now. The virtual private gateway is pointing to what? It's pointing to databases, because most time your database is not expected to be on a public subnet. We are going to look at subnet tonight, and we will understand why we need the situation where you need an internet gateway and where you need a virtual private gateway. So you can see the connection from your corporate data center. You have your internet, but you still have a VPN connection. And then from your corporate enterprise data center now going, you will come into you now use the virtual private gateway to access your private resources. Don't worry, we understand as we move on. So now you can see it now. public traffic is coming. When public traffic comes in, the virtual private gateway will drop it, but it will take the private traffic that is coming from a known VPN connection in order to access it. And when it comes in, it goes to the database. You can see that the arrow goes to the what? To the database, which is in the private network or resources. All right. Read this for us, Miss Regina.
Okay. AWS Direct Connect. This is a service that enables us to establish a dedicated private connection between your data center and our VPC in AWS Cloud. Direct Connect allows us to establish a completely private, dedicated fiber connection from our data center to AWS. We work with Direct Connect partner in our area to establish this connection. AWS Direct Connect provides a physical line that connects our network to our AWS TV. Suppose that there is
Thank you. I think we are fine there. Now, do we understand what this AWS Direct Connect does? Do you understand it? Now, we said this is a service that enables us to establish a dedicated private connection between our data center and our VPC in AWS Cloud. First thing, your VPC is your own private cloud inside AWS, where you have all your resources. Now, you don't just want to be using the public internet because of latency. You now have a dedicated fiber link. Are you hearing me? Dedicated fiber link from your data center to AWS Cloud. You can imagine. Only you sharing that link. Nobody else is sharing it with you.
Only one person, no.
Yes, only your company. The private connection that AWS Direct Connect provides help you to reduce what? Network cost and increase the amount of bandwidth that can travel through your network. You can see that.
But it's fiber.
It's fiber, yes. Now the question is, how do we do it? What they do is they already have. Somebody has a question?
That's what I wanted to ask. How did they do it?
Oh, good. Thank you. Now, AWS Direct Connect, what they do is they have connections with some major service provider, like May1, for instance.
Like May1.
So what you will do is to get a dedicated link from May1 to your office. Okay. And in May1 data center, you will now do a cross connect there. So there will be a switch in May1 where AWS is connected to, you two will now connect to that switch. From that place, both you and AWS, you are on a direct dedicated link. They call it NNI, network to network interface. Did you get that?
Yeah, we did it earlier.
I explained that, right? Before.
Yes.
Okay. Look at the direct connect now. Look at the diagram. You see your data center direct connect traffic to AWS Direct Connect. Only you, nobody else. You can see direct connection or direct connect location, customer router, customer or partner router. Now you see this partner router can be what? Can be May1, for instance, or any giant internet service provider. Then to your resources. Now, this is where we are going. Subnet and network access control list. Someone should read this for us.
Subnet. A subnet is a section of a VPC in which you can group resources based on security or operational needs. Subnets can be public or private. Now, public subnets contain resources that need to be accessible by the public, such as an online store's website. Private subnets contains resources that should be accessible only through your private network, such as a database that contains customer personal information and other histories.
Thank you.
In
Did you see that now? This is where we are going now. We have what we call public subnets and what we call private subnets. Imagine, do you know that anytime you are supplying your ATM PIN, there is a database that is collecting your information? So that database is expected to be in a private subnet, whereby it is not everybody that have access to that information. Because if everybody have access to that information, what happened? They can take your PIN and use it to, you understand?
They can hack it.
Exactly.
They will
so
just change your
whatever it is they can do from there. In a VPC, subnet can communicate with each other. For example, you might have an application that involves Amazon EC2 instance in a public subnet communicating with database that are located in a private subnet. Listen now, within the organization, subnet can talk to each other, but you cannot come from outside and hit a private subnet. Did you get? So,
come again, sir.
Okay. Look at this diagram. I will explain from here.
Okay.
If you are coming from outside here, you cannot directly hit this private subnet. If you want to hit the private subnet, you must use a virtual private gateway, telling us that you are the true user. If you use a public internet gateway and try to come into private subnet, it will not. The only thing is, what we are saying is that public subnet can talk to private subnet. That is, sometimes people here, these resources, want to talk to these resources. Yes, it's possible. But you cannot come from outside using internet gateway to try and reach this private gateway. So this is what we are saying.
But public internet gateway can access public subnets.
Exactly. That is the purpose of it.
Okay.
Yeah. So we move on. So this is what we are saying here. Cashier, barista, we've explained all of this before. Customer want to go directly to try to get their order directly to the barista. We are saying no, but they can do it. But what we now do the next time is we stop it. So we put the barista in a private subnet. Do you understand what we are saying here? Look at it here. If the two of them are in public subnets, the cashier and the barista, remember the cashier is collecting money, collecting order, and the barista is the one serving the coffee, right?
The one serving the coffee.
Now, because there is both of them are in public subnets, right? This person can decide to come here and collect his coffee because it's public.
Without paying.
No, he can even pay, no problem.
Okay.
You understand?
Okay. Yes.
But what you can now do is, if you don't want this to happen, you put this guy in a private subnet.
Okay.
You understand? But this one will remain in a public subnet. Every customer can access her, but they cannot access the barista. Do you get?
Yes, sir.
So that's why we now have it this way. You now see, you see this green is saying public subnet, the blue is saying private subnet. Learning more about the role of subnet within a VPC, let's look at the coffee shop. I think we've explained this. First, customer give their order to the cashier. The cashier then passes the order to the barista. This process allows the line to keep running smoothly as more customer comes in. Suppose that some customer try to skip the cashier line and give their order directly to the barrister, right? This disrupts the flow of traffic and results in customer accessing a part of the coffee shop that is restricted to them. To fix this, the owner of the coffee shop divides the counter area by placing the cashier and the barrister in separate workstations. The cashier workstation is public facing and designed to receive customers. The barrister area is private. The barrister can still receive order from the cashier, but not directly from customers. Do we understand this? This is similar to how you can use AWS networking services to isolate resources and determine exactly how network traffic flows. So we move on. In the coffee shop, you can think of the counter area as a VPC. The counter area divides into two separate areas of the cashier's workstation and the barrister's workstation. In a VPC, subnets are separate areas that are used to group together resources. So subnet is like our workstation area that we are saying, or counter. So network traffic in a VPC. When a customer requests data from an application hosted in the AWS cloud, this request is sent as a packet. Note what a packet is. A packet is a unit of data sent over the internet or a network. It enters into a VPC through an internet gateway. Before a packet can enter into a subnet or exit from a subnet, it checks for permission. That's where we are going. This permission indicates who sent the packet and how the packet is trying to communicate with the resources in a subnet. So the VPC component that checks packet permission for subnet is a network access control list. The VPC component that checks packet permission for subnet is a network access control list. Let's note that. All right, so we move on. Network access control list, ACL, it's called ACL. A network access control list is a virtual firewall that controls inbound and outbound traffic at the subnet level. You see this? This is being done at the subnet level, that is, at whether it's a private or a public subnet. Each AWS account includes a default network ACL. When configuring your VPC, you can use your account default network ACL or create custom network ACL. By default, your account default network ACL allows all inbound and outbound traffic. Please note this. By default, our account default network ACL allows all inbound and outbound traffic, but we can modify it by adding our own rules.
So we can customize it.
Exactly. For custom network ACL, all inbound and outbound traffic is denied. If you customize it, it will be denied until you add rules to specify which traffic to allow. Additionally, all network ACLs have an explicit deny rule. This rule ensures that if a packet doesn't match any of the other rules on the list, the packet is denied. All right. Stateless packet filtering. Understand this, we have what we call the stateless and the stateful. Now, network access control list performs stateless packet filtering. What do they mean by stateless? They remember nothing and check packets that cross the subnet border each way, that is inbound and outbound. What they are saying is, when you send traffic in, it will check for this thing. When the traffic is coming back again, it will still recheck it again. It's just like when you pass police officer now. Take for instance, you drive past a police officer. He has checked your car when you were going. When you are coming back again, He's still checking your car. You understand? But you know, some will say, but I've checked him before. There is no need to check him again. You understand? So stateless is saying, I don't remember I've checked you before, so I'm going to check you again each time you are coming. Do you understand?
Yes, sir.
All right. This is similar to sending a request out from an Amazon EC2 instance and to the internet. When a packet response for that request comes back to the subnet, the network ACL does not remember your previous request. The network ACL checks the packet response against its list of rules to determine whether to allow or deny. After a packet has entered a subnet, it must have its permission evaluated for resources within the subnet, such as Amazon EC2 instance. The VPC sub-component that checks packet permission for an EC2 instance is a security group. Note this. The VPC component that checks packet permission for an EC2 instance is security group. Now, remember that here we say network access control list. The VPC components that check what? Permission for subnet is what? Network access list. So for subnet, it's network access list. Why for EC2 instance is what? Is security group. Okay. We move on. So what is security group? A security group is a virtual firewall that controls inbound and outbound traffic for an Amazon EC2 instance. Do you see this? So
Yes.
you must be able to distinguish between, security group and network access control list. Your security group is for Amazon EC2 instance, while your network access control list is for your subnets.
Okay.
So either private or public.
Public.
Yeah. By default, a security group denies all inbound traffic and allow all outbound traffic. By default, it denies all inbound traffic and allows all outbound traffic. You can add custom rule to configure which traffic to allow or deny. If you have multiple Amazon EC2 instances within a subnet, you can associate them with same security group or use different security group for each instance. Stateful now. Remember, I've explained stateless the other time. So yes. Stateful is just the opposite of stateless. Packet filtering. Remember the previous definition of decision made for incoming packet. The police has checked you when you are going. So the police is not going to check you again.
You when you are coming.
That's exactly what stateful packet filtering is saying. So we can see that what network access control list does what? It checks for what? For public subnets. While security group checks for what? Amazon EC2. Okay. So this is the packet control list. Just see this. All right. Both network access control list and security group enable us to configure custom rules for the traffic in our VPC. As we continue to learn more about AWS security and networking, make sure you understand the difference between network ACL and security group. That is the major thing. You must be able to distinguish between security group and network ACL. You can see security group here. They are working on Amazon EC2. While network access control is, they work on what? On our subnets level. Okay. So now let's check. For this review exercise, imagine that your company is launching an online photo storage application. Help determine which VPC components should be used for certain aspects of the application. In the following, match each part of the application to the correct VPC component. We'll conclude from here. So, Miss Regina, are you here? Hello?
Yes, I'm here.
Okay, now look at this. We will do this and we call it a day. Create a VPN connection between the VPC and the internal corporate network. What do we need here? If you want to create a VPN connection,
private gateway.
huh?
Virtual private gateway.
Okay, now establish a dedicated connection between the on-premise data center and the VPC.
AWS
A dedicated
Direct Connect.
connection. Huh?
AWS Direct Connect.
God bless you. The next one, isolate database containing customer personal information. What do you do there?
Private subnet.
Do you see that this thing is very simple?
Yeah.
And then support the customer facing website.
Public subnet.
You get that? You've got to see this kind of questions. So we look at the next thing. You can see to isolate database containing customer personal information is private subnet. Create a VPN connection between the VPC and the internal corporate virtual private gateway. Support customer facing public subnet. Establish a dedicated connection between the on-premise and data center direct connect. All right. Look at this question. Kyle, they read this question and answer for us.
Which statements best describe an AWS account default network access control list? It is stateless and denies all inbound and outbound traffic. It is stateful and allows all inbound and outbound traffic. It is stateless and allows all inbound and outbound traffic. It is stateful and denies inbound and outbound traffic.
We've just finished that now. We discussed network access control list and security group. So what's the answer here?
Yes.
What's the answer?
Okay, as for access control list, I'm coming now.
Okay. I'll take us back so that it will be easier for us, and next time we can.
No, go back to the question. Let him answer first.
Let me answer first too.
Okay, we answer. We don't have time. We have less than 5 minutes more. That's why.
Yes, I don't worry. I will answer now.
Oh yeah.
Okay, so my answer is okay. It's stateless and okay. My answer is A.
A. Miss Regina, do you think it's correct?
I go for B.
You go for B. It is stateful and allow all. Now, the fact that you say it's stateful already shows that it's incorrect. It's actually stateless. Okay? Yeah, it's actually stateless. But it is now whether it allows or denies. This is it. It is stateless and allows all inbound and outbound traffic. So the answer is
A. Is it not A?
It is C. It is stateless and
allows
all.
Okay.
It is stateless and allows all inbound traffic. It is the security group that is stateful and denies.
Yes, that one for EC2. That one for EC2.
EC2 is stateful and denies all traffic. You see it here now. Okay. Security group performs stateful what? Packet filtering. Always have that one in mind. Security group is stateful.
When you log in, who ask you again?
Yes. So they remember previous decision making. Okay. Now look at this. By default, a security group does what? Denies all inbound and allow all outbound. It denies all inbound by default. It denies all inbound by default, but allows. So tomorrow we're going to be looking at, I hope we can meet tomorrow. Miss Regina, what time? What's your duty tomorrow? What time?
Normal time now, 1 to 10.
1 to 10. So can we meet in the morning? Or what time do you go to the office?
I leave by 11. I don't, they've not dropped time. I leave by 11.
By to 11, you will leave. So can we meet by early? Is it possible for us to meet early, guys? For now. So
I'll be at work by 1. So let's do 12:30.
12:30. Okay, so tomorrow we're going to start on a global networking. Now, we have been talking a lot about how we interact. So this is what we're going to look at tomorrow. And from there, we look at domains, and then Route 53, we've looked at that before, and we'll call it a day.